Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my BEng Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. BEng Cert Ordinary Level, question 8 from the 2015 paper 1. The daily profit of an oil trader is given by the profit function P is equal to 96x minus 0.03x squared, where P is the daily profit. I might highlight that. P is profit and X is the number of barrels traded in a day. Complete the table below. Okay, so the table, I'm being given a range of values for X, which is the number of barrels, and I'm asked to work out the daily profit. Okay, so when X is 500, then my daily profit P is equal to 96x minus 0.03x squared. So for this case, it's 96 times 500 minus 0.03 500 squared. Okay, so let me put that into the calculator. 96 bracket 500 minus 0.03 bracket 500 squared. So I'm getting 40,500 for that, as shown there. And I find that a very useful exercise. If they've given me an answer, if you can figure out where that answer came from, then you know that your method is right. So then when you go on to do 1,000, it would be 96 times 1,000 minus 0.03 times 1,000 squared. Okay, so 96 bracket 1,000 minus 0.03 bracket 1,000 squared. So I'm getting 66,000 for that. Okay, when X is equal to 1,500 barrels, it'll be 96,000 1,500 minus 0.03 1,500 squared. Okay, so I can leave in the 1,000 and just go back and change that to 1,500 in my calculator if I want. And I'm getting 76,500 for that one. Okay, let's change it to 2,000. And you get 72,000 for that one. And change it to 2,500. So you can see I don't write out every example, but I do show the corrector of the paper that I know the method. And this is where I'm getting the answers. Okay, so number of barrels, daily profit. Okay, part B, draw the graph of the trader's profit function on the axis below for X being between 500 and 2,500. Okay, so I can see the number of barrels and I can see daily profit. These squiggly lines on a graph that are here, very useful. In fact, it just shows that they know the y-axis starts at 0. They just have no data points between 0 and 40,000. So it's kind of like a shortcut up to 40,000. Okay, so my first couple that I'm plotting is 500 and 40,500. So 500 and 40,500, so just a little bit above there. 1,000 and 66,000. Would be somewhere here. 1,500 and 76,500. There's 75. Would be there. 2,000 and I'm down to 72,000. Be below there. This one is might be a little bit lower. Okay, and then 2,500 and 52,500, which is halfway between those two. Okay, and then I join them as best you can in a curve. So it doesn't come out of 0 because we only start at 500. I took a speed wobble there in the middle, so let's try it again. Okay, so as smooth a curve as you can do it around it. Okay, and that's your P graph. Okay, use your graph to estimate the daily profit when 1750 barrels are traded. Okay, so use your graph. So very important to be able to read off your graph. When they give you a number of barrels, for example, you go to the axis that mentions barrels, and you, if in this, you come in from the barrels axis. If they gave me a profit and they asked me a question on it, I'd come in to my graph from the profit side. But this was a number of barrels. It was 1750 barrels. So I'm going to find that on my x-axis. 1750 is halfway between 1500 and 2000. And what you do is with your ruler, you dot up to your graph until you hit it. Okay? And then you go across and you find out what is the corresponding profit for that amount. Okay, so I am getting 75,000 for the profit when 1750 barrels are traded. Okay, so I hope that makes sense. Go up to your graph and go across. And you can see we'll all have slightly different answers depending on how rounded that top of the graph is. And that's why it always says estimate. So in the answer, the acceptable answers for your Leaving Cert, there'll be a range of values for this. Okay, right. Part 2, the number of barrels that were traded when the daily profit is 60,000. And they've helped you out here by saying answer or answer. So what does that mean? Right, well, let's find 60,000 on our graph. Okay, so I'm going to change color just to come across to my graph at 60,000. Okay, so why is it something or something? Well, you can see there's definitely a point, but if I had kept going, if I do keep going, you can see I touched the graph at another point. So that means there's two x values that gives me 60,000 euros profit. Okay, there's this value here which looks like 750 or thereabouts. That's a bit more actually because that line there is 750, so 840, something like that. And there's this value here which is, that's 2250, so maybe 2,300. Okay, so I reckon about 820 for that first one, and that second one 2250, 2300. Okay, so either of those amount of barrels will give me a daily profit of 600. If my answers vary a bit from the answers in the back of exam papers or the solutions on the web on examinations.ie, don't worry too much about it. It's because I'm drawing my graphs on a digital screen, so they're always out. My screen moves as I'm trying to draw. Okay, so I'm more showing you the method than the precise answer. Okay, part D then. Use calculus to find the number of barrels of oil traded that will earn the maximum daily profit. Okay, and you'll see in the majority of the calculus questions I have done, and we've done quite a few at this stage, we've often had a question that was on max min, and you'll see me always writing down at max min, so max or min points, dy dx equals 0. That's the theory that they're testing. Okay, to find the maximum point of a curve, okay, you let dy dx, which is slope, equal to 0. And the reason for that is right at the top of that curve, your slope is 0. It's a flat line, just right at the peak. Okay, Not here, not here, just right at the peak. Okay, so the number of barrels of oil traded. So I need my function. So P was equal to 96x minus 0.03 x squared. Okay, so that was my P function. I need to differentiate it. So I'm differentiating the equation P with respect to the letter x. So it's a dp dx. You'd lose no marks if you wrote down dy dx. So differentiate 96x and you'll get 96. It's like you throw away an x every time. This one, take down the constant, and then differentiate x squared, and that'll become, take down the 2, reduce the power of x by 1. So I'm getting 96 minus 0.06x. So that's my dp dx. At max min, it's equal to 0. So at max point, dy dx is equal to 0. This would always form part of my question. What I'm writing here in purple is exactly how I would answer an exam question. And I will go 96 minus 0.06x is equal to 0. And I want you to solve it now for x to find the number of barrels. And divide across by 0.06. Put that into a calculator. 96 divided by, I should have minus 96 divided by minus 0.06. And I'm getting 1600 barrels for that. Okay, so does that make sense? 1600. So somewhere here I get the maximum profit. Well, yes, that does indeed make sense. Okay, even from the table, you can see you were up very high profit around 1500. By 2000, you'd already started to fall. So somewhere here is the maximum number of barrels to get, or the number of barrels that will give you the maximum profit. Okay, so part 2 then said find this maximum profit. Okay, so what's the difference? Well, this question says, well, how many number of barrels gave you maximum profit? So how you find the actual maximum profit then is you take this number of barrels and you sub it into your profit equation. So let me take that down again. P was equal to 96x minus 0.03x squared. So when x is equal to 1600 barrels, your profit is equal to 96 times 1600. So this is exactly what we did when we were filling in the table at the start. Okay, and it's equal to 96 times 1000, no, times 1600. Close my bracket, minus 0.03, open my bracket, 1600 squared. So I'm getting 76,800 euros for that maximum profit. Okay. Important that you know what max min is with respect to calculus. And the final part then, part E, the trader will not make any profit if he trades more than K barrels of oil in a day. Calculate the value of K. So he'll not make any profit if he trades more than K barrels of oil in a day. So let's go back to the table and see if that makes sense. So this is daily profit, okay? So you can see he has no profit. Obviously, I think if he trades no barrels of oil, okay? But you can see after a length of time, his profit will reduce back down again. And they want to know what's this value that if he trades that amount, he'll have no daily profit. Okay, and why does that happen? Well, you need more employees, you might need another production line, you might need more machinery, whatever. You'll need to make a huge amount more, and sometimes it just doesn't pay you. Okay, so this trader should really only do 1600 barrels a day and no more. Okay, but anyway, he said he'll not make a profit if he trades more than K barrels of oil in a day. Calculate the value of K. Okay, well, the profit is 96x minus 0.03x squared. And if he makes no profit, well then that's equal to 0. Okay, so how do I solve that for the value of x, or I could call it k, okay? Well, you could form a quadratic out of it if you wish. You have to solve it for x one way or the other. So I'm writing my x squareds first, then my x, and then my number. Okay, and when it's in this form, you can use the minus b formula. So all I did was stick in this extra plus 0 at the end. I moved him over to the front so that my x squareds comes first, okay? Because every quadratic is ax squared plus bx plus c equals to 0. And that's how I use my minus b formula. Ax squared plus bx plus c equal to 0. Okay, so that's all I did here. My a is equal to minus 0.03, b is 96, c is 0. Okay, so to solve it, minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's put in our values. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let me come up here and do it. So x is equal to minus 96 plus or minus. So I'm going to put all that square root into the calculator. And you get 96 all over minus 0.06. Okay, let's split it into the plus and the minus now. So my first answer is minus 96 plus 96 over minus 0.06. And my second answer will come from minus 96 minus 96 over minus 0.06. So minus 96 plus 96 is 0, so I'm going to get 0 for that one. 0 divided by anything is 0. So for the second one then, minus 96 minus 96 over minus 0.06 gives me an answer of 3200 barrels. Okay, so remember we said he'll make no profit if he trades no barrels, so that makes sense. I'm not surprised to see 0 as a solution. This one then must be my k value. Okay, if he trades 3,200 barrels, he will have no profit. Okay, so you can see if we keep going with that curve, we're not too surprised. 3,200 will have us down at a profit of 0. Okay, so I hope that makes sense. There's another way I want to show you how to do it. Okay, it's very similar. It's just you didn't have to use the minus b formula. So again, I'm going to solve him. So p is equal to 96x minus 0.03x squared. Okay. Sorry, I'm in the wrong place. Same equation, but I want to show you a different way of solving it. Okay, so what I'm saying is 96x minus 0.03x squared equal to 0. The other way of doing this, of solving this type of equation that doesn't have a c in it, for example, is to factor out the x. Okay, so factor out that x. So x by what gives me 96x. So it's 96. This is taking out the highest common factor from junior cert. Take out one of the x's over here and you're left with minus 0.03x. Okay, equals 0. And at this point you can let each factor equal 0. So x is equal to 0 is one of your solutions. Do you see it there on the outside? And this then is your other solution. So 96 minus 0.03x equals 0 is your other solution. And solve that for x. Okay, and you will also get x being equal to 3200 for that one. Okay, so this is another alternative to how to solve an equation like this. Either way, KE is equal to 3200 barrels.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.